Hello guys, welcome to Deep Codes, and in today's video we will discuss GFG daily problem, that is fill the matrix of the day 21st of February, right? So here in this question, fill the matrix, it is of a type medium, and here you will be given one matrix but not a complete matrix, only the dimension and quotient, that is the number of rows into number of columns, and you need to fill the matrix with ones. So initially there will be only one there at position at x and y, that is these are the coordinates of the one, and with this one you need to fill the complete matrix with ones, right? And each time in one iteration you can travel into four neighboring elements from this one. So let's say you are given this type of matrix with where there is only one at this position x comma y, so x is 2 and y is 3 at this position, and with this you can travel in the four direction, like left, top, right and bottom. So in this four direction you can travel and make convert the zeros to 1, correct? Got it? So you need to convert the zeros to 1 with the help of this one, correct? So in the iteration 1 there are only two neighboring elements it can travel, that is this rightmost and the topmost, the right and top of this one. So it converted these two zeros to 1. Now with the help of this to 1 we convert again these two zeros to 1, as you can see here. Now with the help of these two ones we convert this 0 to 1, correct? So after the third iteration the complete matrix is filled with 1. So how many iterations we require to completely fill this matrix with 1? 3 iterations. So yeah, we written 3 as our answer. Got it? So if you take a look at this second example, there is only one cell in the matrix, so yeah, 0 iteration, correct? So yeah, this is the case. And if you see about total constant, then there are the size is 10 to the power 3. So yeah, the number of rows and number of columns are restricted to 10 to the power 3. So let me show you here that let's say if you have something like this, some matrix like this. So initially what is here, there is only one here, then all are 0. The complete matrix is 0. This is something that you are given. At the one cell is filled with 1 and all other cells are filled with 0, and you need to completely fill the complete matrix with 1, right? You need to fill all the cells of the matrix with 1, correct? So what you do, so here what you can do with this one, you can travel in up, left, down and right. Okay, this four direction you can travel. So here there is one, so in at one iteration you can travel to these two cells. So let me write is I1, that is iteration 1. So in this iteration 1, what you make, this convert 0 to 1 and also convert this 0 to 1, correct? Right? So after this is 1. Now with this one you can travel to here and here, right? Top and left. And also with this you can travel to this and this. So yeah, in iteration 2 you make this to 1 in iteration 2, this also to 1 in iteration 2, and this also to 0 to 1 in iteration 2, correct? Now these all three are 1. So with the help of this you can travel to this, you can travel to this. This is not visit, means you can't travel diagonally, correct? So in iteration 3 this is converted, in iteration 3 this is also converted, and afterwards you can convert this 0 to 1 in iteration 4. So how many total iteration required? 4 iteration required in this example. So actually what you are doing here is, say let me show you this same thing in form of a tree or a graph, you can say. So let's say you have something like this. So let's say this is some tree you have. Okay, so initially let's assume that only this is 1. So assume that this tree with index 0 is 1, and you need to completely fill all the other indexes to 1, correct, as you are doing in the matrix. So what you do, from this one you travel to its adjacent, this. Now once you make this, means in iteration 1 you make all the zeros to 1, then iteration 2 what you do, you make all the adjacent of previous to 1, correct, and iteration 3 you make the adjacent of iteration 2 elements to 0 to 1. So this is iteration 3. So what you are doing here, this is what level order traversal. Level order traversal. And what is level order traversal? Level order traversal is nothing but breadth first search. The breadth first search means we are traveling all the possible adjacent element at a time, and we are converting that zeros to 1. Then again traveling adjacent possible elements and converting them zeros to 0 to 1 until what? Until no 0 is remaining. Okay, so this is what, this is simple as it is breadth first search, and the same breadth first search that we use in trees and graph we will apply here, apply in the matrix. How we will apply? We will apply as the same way, either traversing from this initial one to up, down, left and right, then we're converting this from zeros to 1, then again taking this converted zeros to ones of iteration 1 to travel to iteration 2, then using iteration 2 to travel to iteration 3. So I hope you guys understood the intuition, how we are traversed, how we got the idea of using breadth first search in this question. Yeah, right. And yeah, with the help of this breadth first search approach we can convert all the elements of the matrix in from 0 to 1. So yeah, now let's move on to the coding part where we will understand the complete thing in much more detail. So yeah, this is the code. As you know that in breadth first search, what we use Q data structure. But you might see that I have taken here a pair like int comma int. Why pair? Why? This is a pair because we have to travel the matrix. Now what does matrix have? Matrix have coordinates, x and y coordinates, and in order to store a cell of a matrix we have to use coordinates. So yeah, that's why I have used coordinates to store. I store coordinates in the Q. And if you are thinking that why x minus 1 y minus 1, to convert this to zero indexing. So yeah, that's why I stored x minus 1 y minus 1, correct? So the first step is clear. For a BFS we need Q, and that would be the pair to store the coordinates. Now the second thing is I build this matrix, right? Here we were only given dimension, so from the dimension I build the matrix and initialize with the 0, and just mark the this given coordinates as 1, right? This is the initial value of 1, right? So yeah, that's why I push x minus 1 y minus 1 and mark the coordinates x minus 1 y minus 1 to 1, correct till here? Now you guys will know that in breadth first search what we do, we simply traverse this queue, right? We simply traverse this queue. So how we will traverse this queue? See, for each element, as you know that for this cell, for this type of matrix, from this one you traverse to what? In top and left. So yeah, we selected the current element, current x and current y, and traverse in all four possible direction. So this is x minus 1, this is top, this is down, this is left, and this is right. So we traverse in all four direction, right? By checking the condition, means why we check this condition, so that we don't go out of the matrix. So to handle the out of bound condition, we use this greater than equal to 0 or less than equal to, same here. Just we can't go here, right? There is no matrix here, we can't go down, there is no matrix for this element. So in order to handle out of bound error, we use this condition, correct? And only if this element is 0, right? Means if let's say you are at here and at here, now the down element is already 1, then do we need to change to 0 to 1? No, we don't need to change. So we are only checking if that element is currently 0 in the matrix. So yeah, that's why we build this matrix, correct? So yeah, based on this we traverse level by level. So how to traverse level by level? So let's say if you have made this both adjacent zeros to ones. Now at the second level is this is the second level, correct? Then this would be the third level, right? And from this third level you will traverse fourth level. So this by this, level by level, that each time how many elements present in the queue that are at the level, and we traverse all those elements at a time. So that's why after each iteration we are doing count plus plus, correct? So yeah, this is how this code works. That this is a simple binary search approach that we are using, but just with a case with a matrix. And in a binary tree we used to check left and right. So instead of left and right we are checking top down, left and right, for condition. Simple as it is. So that's for the coding part, and at the end we are returning count minus 1. Why count minus 1? So as you can see here, this took iteration 0, 1, 2 and 3. So our count will start from 0, then it will give us the result 4 at the end. But the initial iteration we don't need to count. As you can see, iteration 0 is, there is no need to count that. So yeah, that's why to return 3 we do count minus 1. Overall it was 4 iteration, but we took the first iteration as a 0 iteration. So yeah, that's why we return count minus 1. So yeah, I hope you guys understood the coding part for this question as well. So yeah, that's all for this video. Now talking about the time and space complexity. So the time complexity here would be what? Would be big of number of rows into number of columns n into m, because these are the total cells present, total number of cells we are traversing. So that this is the time complexity, and the space complexity is also the same, n cross m, the total number of cells, because here we are building this matrix. So yeah, this is the time and the space complexity. So yeah, that's all for this video. If you have guys any doubts related to this question, then do let me in the comment section. Make sure you like this video and subscribe to our channel. Thank you.